Those are online are able to hear me?
Yes, sir.
Okay. Yeah. So what did we see in the previous class? Sorry. So in the previous class, we saw an activity, right, that is related to the concept of paramagnetic, ferromagnetic substances. கொஞ்சம் இப்படி தள்ளி உட்காருங்க, camera ல வரும். இங்க இன்னும் வருது. இங்க வந்துருச்சு. Okay. So we have seen about how a paramagnetic substance, diamagnetic, and a ferromagnetic substance will respond to the external magnetic field. You remember that? So previous class, I showed you a video, no? Right? I showed you a video where how these substances are going to respond to each of the external magnetic field. Attend panniya? Wednesday, last Wednesday. நடுவில் போயிட்டு இருக்கேன். Wednesday only I showed, no? கடைசி I showed. I showed. அதான் சொல்லு. So now what we are going to discuss is, even before we try to understand how the paramagnetic, ferromagnetic, and diamagnetic substances are going to respond to the external magnetic field, we need to know certain terms that are related to magnetic substances. So we are going to discuss 8 different terms that are there. Okay. And they are very, very important at the same time. They appear to be similar. So pay attention to this. Right. So having said this, first, we'll get started with the first term, that is magnetizing field. Right. So what is it? First, we are going to discuss about the concept of magnetizing field. Okay. Let's not think too much. Listen. Let's not think much, but you see, I have a bell pin where I'm keeping it on my hand. I have a bell pin which is kept at hand. I have a bar magnet in my hand. Observe what I'm going to do is, I'm going to take this bar magnet closer to this bell pin, but I'm not going to touch it. What am I doing? I'm going to take it closer to the bell pin, but not going to touch it. So when I take close, did you observe what happened? Did I touch it? You could see if you record it in slow motion, right? Can you do that for me? So just switch on the slow motion. Okay, just focus on this. I have focus on this. Right? So I take it close, observe what is happening. Right? So cut it. It's always good that you observe things. When I don't know how it has come, but let's see. So, yeah. Let's see if it is actually flying. Even I'm curious, but I don't. Those who are online are able to see?
Yes, sir.
Yes, sir.
Okay. ரொம்ப ஸ்லோவா இருக்குடா. ஸ்லோ மோஷன் தான், அதுக்கு நீ இவ்வளோ ஸ்லோ ஆவா? இது எடிட் பண்ணி தான் போடணும் போல. இப்பதான் கையே கீழே இறங்குது. Nice, no? So, what is happening? We could understand that magnetic force is greater than the gravitational force, right? Cut பண்ணல. Okay, listen. Now, why I did this activity is for you to understand what is magnetizing field. Can you tell me what is magnetizing field in the activity that we did? Hey, what is magnetizing field? Name itself is suggesting, no? Something that can magnetize a material, right? So if I take this example, what was happening? This magnet had a field around it, and there was some magnetic field getting induced in this bell pin, due to which there was a non-contact force, and then the magnetism induced. So what pole should get generated? If I take the north pole closer to this should become south pole. Only then attraction is going to take place according to the basic properties of magnet, right? Now, let's understand what this magnetizing field is. So when a magnetic material is placed in a magnetic field, what is the magnetic material in the example that I did? Bar magnet is not the magnetic material. Bar magnet is the magnetic material. Sorry, the bell pin is the magnetic material, right? When a magnetic material is placed in a magnetic field, who's generating that magnetic field? Bar magnet, right? What will happen? A magnetism is induced in it. We could see it. What is the meaning of induction? That there is something that is happening without any physical contact. That is why it jumped, right? Happening without any physical contact. The magnetic field that exists in vacuum and induces magnetism is called magnetizing field. It's called magnetizing field. For example, they have given a toroidal solenoid, or you can think of a solenoid also. If there is an electromagnet solenoid which is carrying current I and it is placed in vacuum, we know that the magnetic field produced due to the solenoid is going to be mu naught times N into I. So near to the solenoid, if you take a magnetic substance, the example is again a bell pin. What will happen is you can see that the bell pin will get magnetized. Then this field mu naught into N into I is what is called as the, tell me correctly, it is what is called as the magnetizing field, because it is inducing magnetism in the magnetic substance. Am I clear with this? See, these terms are very important because when you read a question itself, no, or any statement that they give, these are all the words with which they will play. Magnetic substance, magnetic material are the same. So magnetic substance and magnetic materials are the ones which are experiencing the force. Magnetizing is something which is creating the force. Am I clear with that point? Right? So this field mu naught into N into I is called as the magnetizing field caused by the so-called free current in the solenoid. It's produced by the free current that is there in the solenoid. Am I clear with this? So just make a quick note of it. First, you can write down the heading as basic terms used in magnetism. Shall I proceed? Or you're writing? Right. Make it fast. Those are online, are you able to understand?
Yes, sir.
Yes, sir.
Okay. Wednesday? I'll start next chapter. Electromagnetic induction. Okay. So the next term that we are going to see is magnetic induction. So what will happen is, due to the magnetizing field, so I'm only going to use these two examples, okay? Due to the magnetizing field, magnetism is induced in it. Accepted? Right? So, but here, in the system, when I say system, what do I mean? I'm talking about the magnetic substance. Sorry, I'm talking about the magnetic substance and the magnetic material itself. Okay. So if I take the magnet and the magnetic substance, what is going to happen is, due to this magnet, there is a magnetic field induced in it. One. Secondly, this material already has a magnetism associated with it. So the sum of the already existing magnetism plus the magnetic plus the magnetism induced in this material is what is called as magnetic induction. So magnetic induction is sum of what? Sum of the already existing field plus the induced magnetic field. Make sense? Right? Now, having said that, see here, the only difference is I'm using a bar magnet. In the explanation, we have used a toroidal solenoid or just a solenoid also. You need not be worried about, you need to know about a toroid, nothing. It's basically some electromagnet. Okay. So as shown in this figure, suppose the solenoid is wound around a ring of magnetic material. So this wire is wound around a ring, and that ring itself is a magnetic material. Means that ring is basically the bell pin example in our case. Okay, what will happen is, as soon as you pass the current through the wire, what will happen? There will be a magnetic field generated due to the current within the wire. And there will be some magnetism induced inside the magnetic material. So the sum of these two magnetic fields is what is called as magnetic induction. Make sense? So having said that, let's try to understand. Under the influence of the magnetic field BQ, or you can call it as B naught. Okay, B naught. The magnetic moments of the atomic current loops of the magnetic material tend to align themselves with or against the magnetizing field B naught. Okay, okay. Since we have used B naught here, I'll use it as BQ only. Correction. Okay. So this gives rise to some net current on the surface of the material, and that current is what is called as the magnetization surface current. So what is going to happen here? Due to the current that is already passing within the material, right? This current I is given by us. We connected it to a potential source, and because of that current I, what got generated? Magnetic field BQ got generated, but there is already, magnetic field B naught got generated, which is mu naught into N into I. And due to this magnetic field, what got induced inside the magnetic material? It is BQ. Along with that, what happened is there is a current which is called as magnetization surface current that has got generated in the material. In the sense, if you look at this from the top view, right, in this magnetic material, there will be current that is flowing along the surface of the material. And that current which is flowing on the surface of the material is what is called as magnetization surface current. This is very rarely asked in your exams. Okay, this is for your extra information. But all that you need to understand is the basic of what is magnetic induction. I hope I'm clear. Is there any doubt? You're clear? Okay. Clear with this? Shall I proceed? Okay. Right. So if you observe the current that was there, no, that surface current which I told, due to the surface current, what is going to be the field that will get generated? It will be mu naught into small n into Im. Basically, I'm using the same formula mu naught Ni only. But only thing is, when you talk about the magnetism inside the magnetic material, it is happening because of the surface current. So it will be Im, right? So what are you supposed to write? The magnetizing field, which is mu naught N into I, plus the induced magnetic field, which is mu naught into N into Im, is what is called as the magnetic induction. So this is what is mathematically called as the magnetic induction. Okay. So is that point clear? So for magnetic induction, what is going to be the SI unit? The SI unit is still going to be Tesla, or it is going to be Weber per meter square. In the previous chapter itself, when we were solving, we used this many times. Right? Listen. I is the current that is flowing through the wire of the solenoid. Im is the current that is getting induced on the surface of the magnetic material. Induced na, அது மேல ஒரு current மாதிரி generate ஆகும். இல்லடா சிம்பிள் லாஜிக். சரி, அதை பத்தி ரொம்ப யோசிக்காது, பட் ஐ எக்ஸ்பிளைன் இட். நான் என்ன சொல்றேன்னா, இப்போ இதுதான் மேக்னெட்டிக் மெட்டீரியல்னு வச்சுக்கோ. இதோட சர்ஃபேஸ் மேல what will happen is there will be a small amount of current which is called as the surface current that will flow, because what did I discuss in the beginning of this chapter? I told you, for you to have magnetism getting generated, you need current. So in the magnetic material there is magnetism induced. So the induce arappa, you need to give a justification that there is a current that is inducing it. So that current is what is flowing on the surface. That is what is called as the magnetization surface current. I told an exam perspective as perusa varadu, but it's for understanding. That's it. Okay. All that you need to understand is what is magnetic induction. That's clear. Magnetic induction na rendume sum pannanom. Okay. So the next term that we need to see is this is. See, I'll tell you why I told you these topics are confusing. Look at the name of this topic: magnetizing field intensity. They look similar, no? Magnetizing field intensity, intensity of magnetization. They are not similar. If they are similar, why do we need 2 points? Right? That's where you need to be careful. So look at the basic grammar used in physics. So when I say magnetizing field intensity, when I say magnetizing field, what comes to your mind? What comes to your mind? It is a field which induces magnetism, which can create magnetism in other materials. For example, you tell me, when I'm talking about this bell pin, and bar magnet, when I say magnetizing field intensity, should I speak about the intensity of magnetic field in the bell pin or in the magnet? I should speak about the bar magnet, because this is the one which is magnetizing. Magnetizing means create magnetism in other materials. Okay. So having said that, magnetizing field intensity means the ability of magnetizing field, that is a magnet, to magnetize a material medium. Means the ability of this bar magnet to magnetize that bell pin is what is called as intensity of magnetization of this material. Sorry, I'm sorry. It's not intensity of magnetization. It is the magnetizing field intensity. Okay. It's called as the magnetizing field intensity, and it is expressed by a vector quantity. Right. So you need to make a note here that magnetizing field intensity or magnetic intensity, they both mean the same. They both mean the same. And how are you going to represent the mathematical expression for it? Listen to this carefully. For every term that we are seeing, no, first we will see the definition of it. Second is we will see the mathematical definition of it. So the mathematical definition of magnetizing field intensity is, it is expressed as the number of ampere turns flowing around the unit length of a solenoid. So if I say B for a solenoid is going to be mu naught into N into I. So read the statement carefully. It is the number of ampere turns. Ampere turns means number of turns multiplied with ampere flowing around the unit length of a solenoid. So can I write this as mu naught into capital N into I divided by L? Because small n is capital N by L. Am I clear with this point? So number of ampere turns per unit length is what is called as magnetizing field intensity. So to put it simple, this whole term can be replaced with this magnetizing field intensity, which is given by the expression H. Yes or no? Okay. So this is what is called as H. I hope you are able to connect to the definition. Having said that, what is going to be the SI unit for it? It is number of ampere turns per unit length. So turns does not have a unit. Current has a unit of ampere and length has the unit of meter. So what is it supposed to be? It is supposed to be ampere per meter. So understand, H is what? The number of ampere turns per unit length. That is small n into I. That's what I wrote it there. So B naught is equal to mu naught into N into I. What is this B naught? This is the magnetizing field. This is the magnetizing field. So mu naught into N into I. So N into I is going to be capital H, or capital H can also be written as B naught divided by mu naught. Make sense? It is going to be B naught divided by mu naught. And this is a very, very important.
Sir, magnetic field intensity na the detail material to magnetize it, adu vandu to get magnetized, sir.
இல்லடா சிம்பிளா சொல்றேன் கேட்டுக்கோ.
இல்ல சார், இது வந்து மேக்னடைஸ் பண்ணுது, அது வந்து to get magnetized. அந்த substance வந்து magnetize ஆகுது.
கரெக்ட். So magnetizing field intensity na இந்த பார் மேக்னெட் தான மேக்னடைஸ் பண்ணுது.
அதோட intensity.
So இதோட intensity தான் magnetizing field intensity.
அந்த substance ஓட intensity வந்து next
topic. புரியுதா? ஆம்பியர் டர்ன்னா கேபிட்டல் N by L தான். ஆக்சுவலா ஃபுல்லா படிச்சு பாரு. நம்பர் ஆஃப் ஆம்பியர் டர்ன்ஸ் ஃப்ளோயிங் அரௌண்ட் த யூனிட் லென்த். N by L, கேபிட்டல் N by L. கேபிட்டல் N by L தான் நீ ஸ்மால் n எழுதுற. அதனால தான் H is written as small n into I. இதெல்லாம் பேஸ் பண்ணி என்ன பண்ணுவாங்க, லாஸ்ட் ஒரு ஈக்குவேஷன் ஒரே ஒரு சின்ன ஈக்குவேஷன் ஒன்று டிரைவ் பண்ணும். அண்ட் அதை வச்சு தான் we'll discuss about the paramagnetic, diamagnetic and ferromagnetic substance. So அதனால அது புரியணும்னா இதெல்லாம் புரியணும். அதனால தான் I'm going very slow. This topic will take time. ஏன்னா இது கன்ஃபியூசிங் டேர்ம்ஸ் எல்லாமே. Number of turns into I divided by capital L. So actually what should have been written is இங்க எழுதிருக்கு. Now it makes sense. Capital N into I, that is ampere turns. Ampere turns per unit length na small n into I. அது H. நம்ம ஏன் small n into I H ன்னு எழுதுறோம்னு இதுல புரியுதா? ஏன்னா you are taking first length எந்த மெட்டீரியலை வந்து we are taking as the magnetizing material? Solenoid. So solenoid ஓட magnetizing field எவ்வளவு? mu naught into N into I. அந்த N into I தான் will decide the extent to which it can magnetize a material. ஏன்னா mu naught is a constant. அது கான்ஸ்டன்ட். பட் வாட் கேன் சேஞ்ச்? நீ வந்து இப்போ நீ வந்து நாளைக்கு ஒரு சாலினாய்ட் டிசைன் பண்றேன்னா நீ என்ன சேஞ்ச் பண்ணலாம்? வாட் இஸ் இன் யோர் கண்ட்ரோல்? நம்பர் ஆஃப் டர்ன்ஸ். நீ 2 டர்னும் போடலாம், 4 டர்னும் போடலாம், இல்ல 10 டர்ன்ஸும் போடலாம். தட் இஸ் இன் யோர் கண்ட்ரோல். பட் மியூ நாட் யூ கேனாட் சேஞ்ச். அதே மாதிரி கரண்ட் நீ கண்ட்ரோல் பண்ணலாம். யூ கனெக்டட் டு 2 வோல்ட் பேட்டரி, ஒரு கரண்ட் ஃப்ளோ ஆகும். 10 வோல்ட் பேட்டரி, ஒரு கரண்ட் ஃப்ளோ ஆகும். ஸோ இது ரெண்டுமே நம்ம கையில கண்ட்ரோல் இருக்கு. ஸோ நம்ம கையில கண்ட்ரோல் இருக்கிறதுனால தான். ஸோ எப்பவுமே திஸ் இஸ் இன்புட். சி பேசிக்கலி வெரி சிம்பிள் ரா. The whole concept is going to revolve around two things. You are going to give an input and you are expecting an output. So input is given to whom? Input is given by whom? Input is given by solenoid. Output is experienced by the magnetic substance. So another magnetizing அப்படின்ற word வந்தாலே எல்லாமே related to input. Magnetization அப்படின்னு வந்தா எல்லாமே related to output. So that is what he asked me. He asked me, sir, இப்போ வந்து magnetizing field intensity is this topic, magnetization next topic ன்னு கேட்டான். So he was right. புரியுதா இது? So now we are going to see intensity of magnetization. Magnetization another already magnetic field is generated. So now I'm going to talk about bell pin, the extent to which this got magnetized. Correct? Huh? When a magnetic material, a bell pin is placed in a magnetizing field in the presence of bar magnet, it gets magnetized. Understood? The magnetic moment developed per unit volume of the material when placed in magnetizing field is what is called as intensity of magnetization. So either there should be some measuring parameter. What is the measuring parameter? The amount of magnetic dipole moment generated in this per unit volume. Are you able to understand what I'm saying? Am I clear or not? I'm saying intensity of magnetization, if I write it as capital M, this is going to be equal to how much? The amount of magnetic dipole moment developed per unit volume. In whom? In this bell pin. Is it clear? Okay. So, for magnetic induction, you remember I wrote a formula. I wrote sum of two terms. What was it? Mu naught into N into I plus mu naught into N into IM. You remember this IM? What is that IM called as? It is a magnetization surface current. That is going to flow on whom? On the magnetic substance. So, இப்போ என்ன சொல்றேன்னா, if IM is the surface magnetization current set up in the solenoid of cross-sectional area A and having n turns per unit length, then the magnetic dipole moment that is developed per unit length in the solenoid is going to be solenoid, the core of the solenoid. எவ்வளோ? Small n into IM into A. Right? It is going to be small m into IM into A. So, prepare. Listen to this carefully. I have a solenoid. This is the core of the solenoid. On the surface of this material, what is flowing? Magnetization surface current is flowing. Is it clear? So, what are they saying? This magnetization surface current multiplied with small n multiplied with area is going to give you what? See, listen to this. If IM is a surface magnetization current set up in a solenoid of cross-sectional area A, the solenoid has a cross-sectional area A, and let's say the length of it is going to be 1 unit. Okay? Or let me take it as L itself. So what is going to be the formula for magnetization in terms of these values? So what is going to be capital M? Capital M is going to be the amount of dipole moment generated in this. What is the amount of dipole moment generated in this? Amount of dipole moment generated in this is N, that is the number of turns in it, into IM into area of cross section. Dipole moment solrenda. Dipole moment formula enadhu? NIA va? The whole divided by what is going to be the formula for volume? Volume is capital A into L. So capital A and capital A get cancelled. Capital N divided by L is small n. So this will be equal to small n into IM. So now you will understand it better. See, when I spoke about the magnetizing field intensity, it is N into I. I is the current flowing through the wire. Whereas magnetization, intensity of magnetization is given as, is it not looking similar? N into I only. But what is the difference? This is IM because it is the current getting generated due to the induced magnetic field. So this is small n into IM. Are you able to understand? Am I clear? Are you done? So don't write everything. Just write down what the mathematical statement which I wrote and clear.
Sir,
denominator
இருக்குல்ல சார்
எதுடா?
அந்த நீங்க மேல இருக்கிற m is equal to n I m a ஏயும் கேன்சல் ஆயிடுச்சு.
என்ன ஆச்சு அதுக்கு?
அது வந்து n I m by l ன்னு வராதா?
இல்லையே. அதான் capital N by small l is small n, no? The capital N into Im into A, this is the magnetic dipole moment. The whole divided by volume is A into L. A and A cancel iduma. What is capital N divided by small n? So small n into Im. இதுதான் வந்து intensity of magnetization.
Okay, sir.
புரியுதா?
புரியுது.
Yes. சொல்லுங்க. அது டோராய்டுடா. ரெண்டுத்துக்கும் ஒண்ணுதான். அதுக்குள்ள சின்ன சின்ன லூப்ஸ் இருக்கும் இந்த மாதிரி. ரொம்ப டீப்பா போகாதடா. நான் சொல்றேன் எது தேவையோ அது மட்டும் சொல்றேன். பட் ஐ எம் எக்ஸ்பிளைனிங் சம்திங் எக்ஸ்ட்ரா. பட் எந்த பாயிண்ட்ஸ் ஞாபகம் வச்சுக்கணும் நான் சொல்றேன். ரொம்ப டீப்பா போனா கன்ஃபியூஸ் ஆயிடும். ஓகே guys, am I clear till this point? Now if you see, so we need to connect the dots now. What do we have? We saw what is magnetizing field intensity. We saw what is intensity of magnetization. Now we need to take the third and the fourth point and connect it to the second point. So what is the second point tell us? B is equal to mu naught into n into I. Mu naught into n into I is going to be the magnetizing field. Plus mu naught into n into Im. It is the magnetized field. Am I right? It is a magnetized field. So when you write the sum of these two, now you know something new. So when I write the magnetic induction now, what I will write is, I will write it as mu naught into, I can replace small n into I with capital H plus mu naught into, I can replace small n into Im with capital M. So this will be equal to mu naught into H plus M. So the same magnetic induction can be written as mu naught times what is H? Intense magnetizing field intensity, and capital M is intensity of magnetization. புரியுதா நான் சொல்றது? So this is another important term that you need to have in your mind. See, if at all so-called problems are asked in this chapter, they'll be asked based on these equations. புரியுதா? Shall I proceed? See, the next term that we are supposed to see is called as magnetic permeability. You already know this. What is magnetic permeability? What is magnetic permeability? It is the measure of the extent to which a material can be penetrated or permeated by the magnetic field. Right? So the magnetic permeability of a material may be defined as the ratio of the magnetic induction to the magnetic field intensity. If you remember, we wrote H is equal to of H. I told you B naught by mu naught. No. Now what you can do is rearrange it. Mu naught will be equal to B naught divided by H. Am I right? So what I can do is, instead of mu naught, because mu naught is the permeability of whom? Of the free space. But here we are not interested about the permeability of free space. We are interested about the permeability of a magnetic substance. Means the permeability of this bell pin. There is not a free space, no? This is a material. So I'm interested, what is the permeability of this material? What does permeability mean? Now read the statement, you will understand. Permeability is the measure of extent to which a material allows the magnetic field to induce it. Am I clear with that term? So what is going to be the mathematical statement? Mu will be equal to, instead of B naught, you will write it as B divided by H. And this is going to be the permeability of this material. Am I clear, guys? Right? So what is going to be the SI unit of it? B is measured in Tesla. H is measured in ampere per meter. So it is going to be Tesla meter per ampere. You already know this. We have been using this, no? 4 to 10 power minus 7 Tesla meter per ampere. Same logic. Now it makes sense. Right? So also you need to remember the dimensional formula, which is going to be MLT minus 2, A minus 2. That's it. Can I proceed? If there is any doubt or any confusing part, please stop me, okay? Those who are online, are you able to understand?
Yes, sir.
Good. Shall I proceed? Or you're copying? Proceed. The next question that we need to understand is relative permittivity. Sorry, permeability. Relative permeability. What is the meaning of it? Permeability of various magnetic substances can be compared with one another. So whenever you talk about relative, what is the meaning of it? Comparison. Right? So permeability of various magnetic substances can be compared with one another in terms of relative permeability, which is represented by the symbol mu r. So how do you define it? Always you remember, okay, whenever it comes to the concept of relative, for example, relative velocity, relative acceleration. Similarly, you have something called as relative density. You have something called as relative refractive index. Relative, I mean, the term under what will happen is you're going to compare. So according to physics, relative has only two operations. Either it can be subtraction or it can be division. So here it is going to be division, right? So when you're dividing, right, when you're writing something as ratio, it is very important for you to understand what should be in the numerator and what should be in the denominator. So listen to this carefully. It is defined as a ratio of the permeability of the medium to the permeability of free space, meaning mu r is always written as mu divided by mu naught, meaning always the known quantity is written in the denominator. So mu naught is written in the denominator. So mu divided by mu naught is what is going to be the relative permeability. I hope you'll not forget it. This definition comes in your exam. And this is very, very important for the table that I told you. Those who are online, am I clear?
Sir.
Okay. So having said that, the relative permeability of vacuum is going to be 1. Because here you'll write mu naught, here also you'll write mu naught. Mu naught by mu naught is 1. Similarly, for air, it is going to be 1.000004. Means air can get slightly more magnetized compared to vacuum. What about iron? Mu r is will exceed 1000. What is the meaning of it? Compared to free space, it is going to have 1000 times more ability to get magnetized faster. That is the meaning of this, or that is the significance of this term. Make sense? We have two more terms. Okay. More is more, more mu r, more faster it can get magnetized. Faster ன்னு சொல்றதை விட better. But faster கூட இருக்கும். அது என்ன வந்து I'll show you அந்த டேபிள் காட்டும்போது உனக்கு புரியும். The doubted? வேக்யூம்னா ஒண்ணுமே இருக்காதுடா. வேக்யூம் இஸ் எம்டி. எதுவுமே இருக்காது. ஆஹா. ஆமா. அப்படி இல்லை, ரிலேட்டிவ்னாலே ஜென்ரலி வாட் யூ டூ லைக் யூ ஜென்ரலி கம்பேர் இட் வித் நோன் குவான்டிட்டிஸ். ஒன்றும் இல்லை, சிம்பிளா சொல்றேன் பாரு. எத்தனை பேருக்கு ஞாபகம் இருக்குன்னு தெரியல, பட் somebody can you tell me what is the definition of refractive index? refractive index to angle க்கு சம்பந்தமே இல்லை. It is also a ratio. It is a ratio of speed of light in vacuum to the speed of light in a medium. In a medium, air அவசரம் இல்லை, எந்த மீடியம் வேணாலும் இருக்கலாம். Speed of light in vacuum divided by the speed of light in the medium. So இங்க என்ன கம்பேர் பண்றோம்? You are comparing it with the known quantity. Cன்றது known quantity இல்ல 3 into 10 power 8. இது மட்டும் தான் வேரி ஆயிட்டு இருக்கும். இது வேரி ஆக ஆக what will happen is refractive index will change. சரியா? நான் எதுக்கு இவ்வளவு ஸ்ட்ரெஸ் பண்ணி சொல்றேன்னா, physics also has a grammar. You need not memorize anything. You understand the concept. அந்த per unit length வரும்போதெல்லாம் if you understand what is the logic, no, you need not memorize at all. நீ எல்லாமே பார்த்தீங்கன்னா, for example, intensity of magnetizing field intensity பத்தி நம்ம என்ன படிச்சோம்? The number of ampere turns per unit length சொன்னாங்க. அவ்வளவுதான ஸ்டேட்மெண்ட். So it is up to you, however you are comfortable. What did they say? Number of ampere turns. Number of ampere turns per unit length by L ன்னு எழுதணும். Per unit length you should not put 1 in the denominator. புரியுதா? by L. அப்ப capital N by small n என்ன ஆகும்? Sorry, capital L by n L என்ன ஆகும்? Small n ஆகும். Small n into I is what is called as the magnetizing field intensity. You need not memorize. ஏன்னா velocity என்னன்னு சொல்றீங்க? சிம்பிளா போலாம். velocity என்னது? Rate of change of displacement. So when you say 5 meter per second, you are covering 5 meters per unit time in 1 second. Is it not the same as 10 meter per 2 seconds? It is just a ratio. அவ்வளவுதானே? இப்படி கூட பார்க்கலாம் நான். So what will happen is 5 meter per second. How will you convey it to someone? 5 meter per unit second. What do you say? 5 meter per unit second makes the same sense as 10 meter per 2 seconds. And the per unit in சொல்றோம், but the unit na you need not always put 1. It can be any time that you put. But அதுக்கு தகுந்த மாதிரி numeratorல the ratio should be in such a way that you get the same result. அதுதான் meaning. Make sense? Right. And the next important term that we need to understand is magnetic susceptibility. ஒரு மாதிரி இருக்கும் ப்ரொனவுன்ஸ் பண்றதுக்கு. It's called susceptibility. Okay. Okay, it is represented by the symbol. You write something like this. It's a Greek letter. It's called chi. You learn about this in electrochemistry also. படிச்சீங்களா? இல்ல, படிப்பீங்க. So chi M அப்படின்னு சொல்லுவாங்க. So M stands for obviously magnetic. So the meaning of susceptibility, see, it's too technical. Susceptibility is something related to a term called as, have you heard this called as vulnerable? கேள்விப்பட்டிருக்கீங்களா? What is vulnerable? The extent to which something can get affected. How sensitive things are. நான் சொல்ற புரியுதா? How sensitive something can be. See, for example, if I say something, different people might take it in a different perspective, and the extent to which they'll get affected will be different. That is the meaning of vulnerability. Okay, so in a similar way, magnetic susceptibility means this is related to the magnetic substance. ஏன்னா, how vulnerable a substance is decided for that substance only. So what I'm going to say is, magnetic susceptibility measures the ability of a substance. What substance? Magnetic substance to get magnetized. இப்ப எனக்கு ஒரு சின்ன லாஜிக் சொல்லுங்க. வயர் இருக்கு, பெல் பின் இருக்கு, this is there. I'm taking the same magnet, I'm taking it closer to this wire. Nothing is happening. I'm taking it closer to this, getting attracted. So out of these two, which one has more magnetic susceptibility? The bell pin, because this is vulnerable. This is getting affected by the external magnetic field faster. This is not responding at all. இதுக்கு என்ன வேணாலும் சொரணே இல்லை அது basically. That is the meaning of it. நீ என்னதான் திட்டிக்கோ, எனக்கு பிரச்சனையே இல்லை. I will be like this one. That is the meaning of this. It is not responding. It is not vulnerable at all. It is strong. Whereas this one, even I take it close, It is responding fast. It's saying, I'm going to come and, it is getting attracted fast. That is the meaning of it. Are you able to understand? Right? So now read the statement, you will understand. What is magnetic susceptibility? It is the ability of whom? Of the magnetic substance to take up magnetization. Magnetization to get magnetized. Right? When placed in external magnetic field. It is defined as a ratio of, so how will you write it mathematically? It is defined as a ratio of intensity of magnetization to the magnetizing field intensity. Basically, நான் ஒன்று சொன்ன ஞாபகம் இருக்கா? Output and input ஒரு term யூஸ் பண்ண ஞாபகம் இருக்கா? I told about. So, out of capital M and H, which is the output. Outputனா magnetize ஆனதுக்கு அப்புறம் வருது. Inputனா magnetize பண்றதுக்கு கொடுக்கிறது. M will be the output, H will be the input. Are you in agreement with it? So, basically, output by input, it is the efficiency. So, simpler சொல்லணும்னா, this is the magnetic efficiency of a substance. How efficient it is to take up magnetization. How efficiently it is able to get magnetized. So, simpler சொல்லணும்னா ஒரு requirement இருக்குன்னு வெச்சுக்கோ. Tomorrow you want to design something. Okay? Somebody is talking to you in terms of magnetic susceptibility. Okay, ரெண்டு பேர் பண்ணிட்டு இருக்கீங்க. Somebody is conveying you in terms of magnetic susceptibility. You want a particular material to get magnetized faster. So what will you convey to the other person? You say you choose a material which has a greater magnetic susceptibility. புரியுது நான் சொல்றது? Right? So it is capital M divided by H. Since capital M and H have the same units, susceptibility is a dimensionless quantity. There's no dimensions or units. Make sense? இதெல்லாம் டிஸ்கஸ் பண்ணாங்களா? அப்ப இதெல்லாம் அப்ப அதுல வந்து மேக்னெட்டிக் அந்த வேர்ட்ஸ் வருமே அதுல, ஆனா எதுன்னு தெரியாது. புரியுதா? இது ஆக்சுவலா this took one class 1 hour நான் பேசிட்டு இருக்கேன் 7 பாயிண்ட். I started at 6:05, 6:57 time. கிட்டத்தட்ட 1 hour I'm talking for 7 points. கம்பேர் ஃபாஸ்ட். இது புரிஞ்சிச்சுன்னா கம்பேரோட 10 நிமிஷத்துல முடிச்சுக்கலாம்டா. உனக்கு இந்த பேசிக் ஸ்ட்ராங்கா இருந்தா கம்பேரிசன் யூ யுவர் செல்ஃப் வில் டு இட். வை ஷுட் ஐ டு? நீயே பண்ணிப்பீங்க. பேசிக்ஸ் ஆர் ஸ்ட்ராங். கரெக்டா? லாஸ்ட் டாபிக். Now we are going to connect all the dots. Right? I have given you everything. Look at it. Relation between magnetic permeability and magnetic susceptibility. Because permeability is also related to the extent to which a material can get magnetized. Susceptibility is also related to the extent to which it can get magnetized. Both are different parameters of measuring it. They are different parameters. So, if you take a linear magnetic material, linear na not length, linear magnetic material na, which follows this thing, B naught is equal to mu naught into H, which follows the format Y is equal to mx format. So that is the meaning of linear magnetic material. Subjected to the action of a magnetizing field intensity. So if any H kuduka, what will happen? There will be a magnetic field that will get induced. So when this is changing, are you in agreement with me that B will also change? You are accepting, no? Because they both are directly proportional. Mu naught is a constant. Either vary agaga, either vary agaga. That is the meaning. So when a magnetic material is subjected to the action of magnetizing field intensity, what will happen? Magnetization happens. Magnetization happens. And I gave you a formula for B. Can you check your notes and tell me in terms of H and M? I just gave two points. I just gave before 2 points. So B is equal to mu naught into H plus M. Why we got it? You remember H is small n into I, M is small n into IM. So the combined money, we wrote this. That is the first step. But according to the concept, what is it we need? We need to relate magnetic permeability to magnetic susceptibility. So B one the mu naught into H plus M. B then the magnetic. Second point, B is magnetic induction. B is magnetic induction. Either H into the magnetizing field intensity, m என்றது intensity of magnetization. Confuse ஆகுதா? வரும். அது ஒன்றும் தப்பு இல்லை. Points அப்படிதான். So I'll come from the beginning. Listen to this carefully, pay attention. B is magnetic induction, H is magnetizing field intensity, M is intensity of magnetization. That's output, is input. This is the total value. புரியுதா? So the B என்றது fifth point பாருங்க. I gave you the relation for permeability, magnetic induction and H. Fifth point. என்ன கொடுத்திருக்கு? B is equal to, I'll do one thing da. I'll write it separately. பாருங்களா. I'll write it separately. So tell me, are you in agreement with this? B is equal to mu naught into H plus capital M. But B, what did I write? Mu naught into H கொடுத்தேன். Mu naught into H கொடுத்தேன். Mu H கொடுத்தேன். Mu naught into H கொடுத்தேன். இல்ல fifth point. Permeable. Mu H தானே கொடுத்திருக்கேன். அட பாவீங்களா, கன்ஃபியூஸ் பண்ணி. B is mu H டா. ஏன்னா mu is the permeability. திருப்பி நான் சொல்றேன் பேர், கன்ஃபியூஸ் ஆகும். நல்லா பார்த்துக்கோ. Mu என்றது permeability of the magnetic substance. Mu naught is the permeability of free space. So B is equal to, இது வந்து this came from, I don't know which number it is, but yeah, after fourth point I wrote. இது fourth point க்கு அப்புறம் எழுதணும். Fifth point க்கு அப்புறம் இதை எழுதணும். LHS is the same. So when LHS is the same, mu H is equal to mu naught into capital H plus M. Makes sense? Now rearrange the equation. இதை பார்க்காதீங்க. Left side, don't look at it. Mu naught divided, sorry. Yeah, mu divided by mu naught is one term. அதான் the sixth term. என்ன பேரு? So mu divided by mu naught is equal to capital H. I'll take it to the other side. It will be capital H plus M divided by H. So if I spread the H to each term, it will become 1 plus M by H. புரியுதாடா? So mu by mu naught, sixth point. Mu R is equal to 1 plus M by H, seventh point. Magnetic susceptibility. So this is the relation of this topic. அதான் கேட்டிருக்கானுங்க. Relation, இப்போ புரியுதா ஏன் படிச்சோம் இதெல்லாம்? To understand this. Okay, this is the basis on which we'll develop a table. அது ஈஸியா புரிஞ்சிடும். Trust me, that's very simple. Okay,
Sir,
சொல்றா.
sir, relation between magnetic permeability தானே இருக்கீங்க. நம்ம relative permeability-க்கும்
இல்ல, magnetic permeability, it's fine, right? You can still write it. இப்போ for example இப்படி இருக்குன்னா, if they ask you the relation between permeability and magnetic susceptibility, இதுல இருந்து இப்படி எழுதலாம்ல. Mu is equal to H அந்த பக்கம் எடுத்துட்டு போயிட்டேன்னு வச்சுக்கோ. Can I write it as mu naught into 1 plus chi m?
ஆமா.
இது கூட சொல்லாமே. This is a relation between magnetic permeability and susceptibility.
ஓகே சார், கேட்டது புரிஞ்சு மாத்திக்க வேண்டியதா?
புரியல, கேட்டது
பொறுத்து நம்ம வந்து மாத்திக்க வேண்டியதுதான் இந்த இத.
Yes. So if suppose there is a problem where they are asking you permeability, அப்ப இந்த formula யூஸ் பண்ணுங்க. Suppose they are asking what is the relative permeability, அப்ப இது யூஸ் பண்ணுங்க. Problem, but relation is almost similar. So the next part is only about discussing the table. For 11 points, 13 points இருக்கும். That 13 points will maximum take 15 to 20 minutes for me. But I don't want to rush because you need to take some time to absorb them. These concepts, these topics are very, very, very confusing. So take time. The next class, I'll complete this. And then we'll go to, there are no problems to do once we complete this. So what I'll do is, the next class, I'll play the same video again. This time, what we'll do is we'll discuss it with even matured idea of how to relate these concepts to that video. அப்போ நீங்களே வந்து ஆன்சர் சொல்லிடுங்க டேபிள் we can learn it faster. பண்ணலாமா அதை? So that we'll do it on Wednesday. Right? Tomorrow there is no class. Okay. So is there any doubt till whatever we discussed? All are clear? Okay. So I suggest you to sincerely work on this and revise these 8 points and come. ஏன்னா இன்னொரு ஒரு ட்ரிக்கி கான்செப்ட் ஒன்று டிஸ்கஸ் பண்ண ஹிஸ்டீரிசிஸ் மெமரி. There is something called as hysteresis loop. So next class வந்து எனக்கு ஒரு half an hour time வேணும் to complete this. Half an hour to 45 minutes. புரியுதா? So revise and come. Those are online. Any doubt?
No, sir.
Okay.
No, sir.
Okay, Raju, we'll wind up.
Thank you.
Thank you, sir.
சாஃப்ட்வேர் கம்மியா இருக்கு. ஏன்னா கேலரி டிசைன் பண்ணுறோம். அதோட வேலை கரெக்ட் டிசைன் பண்ணுறது. ஸோ அது மேக்னெட்டிக் ஃபீல்ட் யூஸ் பண்ணணும் அவசியம். அப்போ அந்த எலக்ட்ரிசிட்டி கம்மியாக தான் இருக்கணும் அப்படின்னு தெரிஞ்சு. அதாவது சாஃப்ட்வேர் பெர்மனன்ட் மேக்னெட்டிக் வேலை ஒரு நாள் போட்டு நாங்கள் நம்ம வந்து செக் பண்ணிப்பேன் இந்த மாதிரி எனக்கு ஒரு எனக்கு வேணும். Electromagnetic transformer generator வந்து generator யூஸ் பண்ணுவோம். Generates ordinary current. Transformer step down step down. Switch code இதன் எவ்வளவு வோல்டேஜ் வேணும். அதுக்கு ரீடிங் ஆஃப் நம்பர் will be 227 226 actual 230. அது ஆல்டர்னேட்டிவ். அது ஸ்டெப் இஸ் 3 227 first rate. It should be somewhere between 220 to 230. இப்போ எனக்கு வந்து ஒரு டிகிரி யூஸ் பண்றேன். இட்ஸ் நாட் டேக் 230. எனக்கு 110 வோல்ட் தான் வேணும்னு சொல்லுவேன். அந்த டிவைஸ் எனக்கு தேவையான 110 டிவைஸ் அதுவும் ட்ரான்ஸ்ஃபர் என்ன பண்ணுவோம் 220 அது 110 பண்ணுவோம். ஒன் ஸ்டெப் டவுன் கிளாஸ். இப்போ 110 இருக்குன்னா 110 இருந்து 220 அதுவும் ட்ரான்ஸ்ஃபர். ஸ்டெப் அப் ட்ரான்ஸ்ஃபர். நான் ஸ்கூலுக்கா Okay. So other one is if a generated transformer the value வந்து what is the correct case does not want you do not want to build your own program. Another is software electromagnetic A for electromagnets equal to A for electric generator A for electromagnet electromagnet use it makes sense. E for electric generator last grade cursor trackpad use trackpad இங்க போயிட்டு ஸ்டாப் இங்க வந்துரும். எக்ஸ்ட்ரா 3 டிவைஸும் கனெக்ட் ஆயிடுச்சு.
இப்படி போகுமா சார்?
இது வராது செட்டதா பட் ஒரு ஸ்கோட்டி அந்த குரூப்ல ஸ்டக் ஆயிடும். எல்லாமே இதுதான் சார் ஆப்பிள் டு ஆப்பிள் அதனால டக் 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 கனெக்ட் ஆயிடும்.
டிவைஸ்
ஆமா எக்ஸ்டென்ஷன் பட் அட்வான்டேஜ் அதனால தான் யூஸ்